Let's calculate the integral of the square root of x plus x divided by the cube root of x. We can see that we have a function where we have roots on the numerator and on the denominator. But on the denominator we just have a root. There's no addition or subtractions that involves other elements. We can see that we have this in common. So applying the integral properties, we could obtain from here two different integrals: the square root of x divided by the cube root of x plus the integral of x divided by the cube root of x. And now what we're gonna do is we have two divisions between fractions. No, I'm sorry, that's divisions, those are fractions. So let's solve this. Let's rewrite this in our way. So we would have x raised to 1/2 as it is square root a root of index 2, so we will have denominator 2, and the cube root would be x raised to 1/3 plus the second integral would be x stays the same, and the denominator would be, of course, x raised to 1/3. And now we can see that in each integrals we have divisions of powers with the same base. So applying the powers properties, we can divide it. That would be, we would have, the first integral is x raised to 1/2 minus 1/3 plus the second integral, that is x raised to 1 minus 1/3. Operating this, we would have the first integral is 1/2 minus 1/3. Let's do it down here. The minimum common multiple between 2 and 3 is 6. So 6 divided by 2 is 3, 3 times 1 is 3, 6 divided by 3 is 2, 2 times 1 is 2, and 3 minus 2 is 1. So we would have 1/6. The first integral would be x raised to 1/6, and the second is x raised to 1 minus 1/3 is 2/3. That's very easy. And this would be equal to x raised to, applying the general formula for integrating polynomials, that is the exponent plus 1, x raised to the exponent plus 1 divided by the exponent plus 1. And the same with the second integral, x raised to 2/3 plus 1 divided by the exponent plus 1, 2/3 plus 1, plus a constant, of course. We cannot forget about it. Operating this, we would have x raised to 1/6 plus 1, that is 7/6 divided by 7/6, plus the second is x raised to 2/3 plus 1 is 5/3 divided by 5/3 again, plus the constant. Operating this again, the denominators, the 6 and the 3 of both of the denominators will go up, so we have 6 times x raised to 7/6, and that can be expressed as the 6th root of x raised to 7 divided by 7, of course, plus 3, the 3 goes up as I told you before, times x raised to 5, but inside of a cube root, because we have a fractionary exponent, divided by 5, of course, plus c, where c is from the set of real numbers, and this will be the result of the given integral.